Section 3.3 interactive assignment, preparing for Section 3.3. We want to be able to organize continuous data in tables. So this example says the accompanying table shows the median household income in dollars for 25 randomly selected regions. We want to complete parts A through G below. Okay, we want to construct a frequency distribution using a first class having a lower class limit of 35,000 and a class width of 5,000. Okay, so what I want to do is I'm going to click on this data and I'm going to open this up into StatCrunch. Okay, so as that's opening up into StatCrunch, I'm going to go ahead and open this up. Okay, now we have raw data. Okay, so given this raw data, we have a lot of values here that we need to look at. So with raw data, what we first need to do is we need to create a bin. And what I mean by bin is we're going to go to data and then select bin, right? And then we want to select the column that we're looking at, which is VAR1. And then we're going to use the fixed width bins. So we're starting at a lower class limit of 35,000. Okay, and we know that our bin width, the class width, is 5,000. Okay, so now we're going to select compute. Okay, now a new column has been added to the data table because now this is going to represent the frequency of each particular class. So now using this new column, we're going to go ahead and then select stat and then go to tables and then select frequency. Now we're going to use the new column, which is bin variable 1. And then here we have highlighted the frequency and the relative frequency distribution. So we're going to go ahead and then select compute. So now we have our information here. So here is our data table. Okay. So the lower class limit for the first one is 35,000. Okay. Now we also need to take a look here that we can't have an upper limit that's 40,000 and a lower class limit of 40,000. So that means that the lower class limits are correct, but the upper class limit is going to be one below that 40,000. So that means that this is going to be 39,999. And so what is the frequency for that one? We can see the frequency is 1. Okay. Next, we know that the next one is going to be 40,000. So that means that the upper class limit is going to be 44,999. And then again, what is the frequency for that class? It is 5. Okay, next we know that the lower class limit is going to be a width of 5,000. So we know it's 45,000, which means that the upper class limit is going to be 49,999. And so what is the frequency for that one? It is 3. Okay, next we know that the lower class limit is going to be 50,000 and the upper class limit is going to be 54,999. And so we can see there that the frequency is 6. Okay, next the lower class limit is 55,000 and the upper class limit is 59,999. So that means that we have a frequency of 3. Next, we have a lower class limit of 60,000, and the upper class limit would be 64,999, and the frequency of that is going to be 5. The next lower class limit is going to be 65,000. The upper class limit is 69,999, and we get a frequency of 1. And then we have a lower class limit of 70,000 and an upper class limit of 74,999. And we can see that we also have 1 as the frequency. Okay, now what we want to do in part B is to construct a relative frequency distribution. So again, we're going to use the first class of having a lower class limit of 35,000 and a class width of 5,000. Well, we've already constructed that, and the classes are going to be the same as the one we just did in the previous example. So we know we have 35,000, and the upper class limit is going to be 39,999. and we can see that the relative frequency is 0.04. Okay, then we have 40,000, an upper class limit of 44,999, and opening up in StatCrunch, we can see that the relative frequency is 0.2. Okay, next we have 45,000. The upper class limit is 49,999. And we can see that that represents 0.12 as a relative frequency. Okay, next we have 50,000. And then 54,999. And the relative frequency is 0.24. And then we have 55,000 with an upper class limit of 59,999. And that's a relative frequency of 0.12. Lower class limit of 60,000. Upper class limit of 64,999. And we end up getting 0.2 for the relative frequency. And then 65,000 with an upper class limit of 69,999. And we have 0.04 as the relative frequency. And the last one is 70,000 for the lower class limit, 74,999. And I believe that has the same relative frequency of 0.04. Okay, now the next question is to construct a frequency histogram. So you want to be able to construct a frequency histogram. Okay, so let's go ahead and do that. So we're going to go ahead and then select graph. Okay, and then we're going to select histogram. We're going to take the variable 1 column. Okay, and again we're starting at the bin. The bin is starting at 35,000. We know that the bin width is going to be 5,000. And then let's put the values above the bar just so that we're good with that. And so therefore here is our histogram. So which one does that kind of resemble here? Well, let's see here. If we take a look at A, does that match? Okay, it's looking pretty close to that so far. So maybe A. Okay, if we look at B, it doesn't match. If we look at D, it doesn't match. And if we look at C, it doesn't match. So it looks like C is our result. Okay, now we want to construct a relative frequency histogram. So let's go back up here. We're going to select options. We're going to go ahead and hit edit. And instead of a frequency histogram, now we're going to put in a relative frequency histogram. So let's go ahead and compute there. So therefore, there is our histogram. So it doesn't resemble part A. It doesn't resemble part B. It doesn't resemble part C. And it looks very similar to what we have in part D. So we're going to check our answer, and there is our result. Now it says to describe the shape of the distribution. Well, if we take a look at this, this creates a bell-shaped or a symmetric shape. So it's neither skewed right or left. So we're going to say that it is bell-shaped, and then check our answer, and there is our result. Okay, now it says in part F, we want to repeat part A through E using a class width of 10,000. So let's go back in here. Okay, and now we're going to again use our raw data. So we're going to take our data and then we're going to go back to bin. Okay, and so now what we're going to do is again, we're going to start at 35,000. Okay, and then our bin width now is going to be at 10,000. And make sure that we have our column selected. So now we have a new column here. So let's call this with new width, just so that we don't get that confused. So we're going to label that as new width. Okay, and now what we're going to do is we're going to go to Stat, and then we're going to go to tables and select frequency, and then we're going to select bin with the new width, and then we're going to highlight both the frequency and relative frequency and then select compute. So now we're going from 35,000 to 45,000. So that means that we're starting again at 35,000. But we know that our lower class limit is going to be 45,000. So that means that 45,000 minus 1 is going to give us 44,999. And so therefore the frequency of that is 6. And then we know that our lower class limit is going to be 45,000. So that means the upper class limit is going to be 10 plus this 44,999. So that's 54,999. And so the frequency for that is 9. Okay, then our next lower class limit is 55,000, which means that adding 10 to this upper class limit is 64,999. And so we get a frequency of 8. Okay, then we know that this one's going to be 65,000, which means that this is going to be 74,999. And we know that the frequency is going to be 2. Okay? And now we're going to do the same thing for the relative frequency. We again know that this is 35,000. And we know this is 44,999. And then looking at the relative frequency here is 0.24. Okay, then we know that this is 45,000. And this becomes 54,999. And that gives us 0.36. And then we have 55,000. And this is 64,999. And the relative frequency there is 0.32. And then we have 65,000 with an upper class limit of 74,999. And the relative frequency is 0.08. Okay? And so now it says, construct a frequency histogram of the data. So let's construct a frequency histogram. All right, so what we're going to do is we're going to go ahead and then we're going to select graph and then histogram. We're going to select our column of VAR1. And now we're going to start at the 35,000. But now our width is changed to 10,000 because that's what they asked us to do. So now the width becomes 10,000. And now we're going to select compute with the values above the bar. Okay, so there is our histogram. So which one does that resemble? Well, it looks like it resembles, let me scroll back down here, sorry about that. Looks like it's between A and D, and it looks more like D. So therefore, it's going to be D. Okay, and then we want to construct a relative frequency histogram. So going to Options, we're going to go to Edit and then change the frequency to relative frequency and select Compute. And there is our relative frequency histogram. So it could be A, looks like A, and that is the best one to choose from. So it's A. Okay, now it says to describe the shape of the distribution. So if we look at this, okay, this kind of resembles what kind of a shape here? Well, it's low here, high here, and then low here. So the distribution, is it bell-shaped? Well, let's check and see. Yes, it is bell-shaped. So therefore, that is our answer. Now it says, does one frequency distribution provide a better summary of the data than the other? And then explain. It says both distributions have a similar shape, so either works well. The shape is not as clear in the distribution with more classes. That's not true. Neither distribution seems to show the shape of the data well. That's not true. The shape is not as clear in the distribution with fewer classes, which is true. So more classes should be used, and that's the case here.